Okay, welcome back. This is part 2 of Calc 1 Exam 3 review. I should have said this in the last video, but in this video, I'm just going over sort of a quick run through of the solutions for this review. Hopefully, you'll be able to use those to help yourself out and get a good grade on this next exam. So we are continuing problem 1, and this is part 6. And in this problem, we're told that the integral of a function from 5 to 6 is equal to 7.2. The integral from 4 to 6 is less. It's 2.5. And we're asked to find out what's the integral from 4 to 5 of f of t. Well, this should become natural, right? This should seem natural. But the integral of 5 to 6 of f of t, and I can draw a picture to justify this, is going to be actually the sum of the other two. How come? Well, these things all represent areas. F of t dt. Oops, this should be a 4. Is the integral from 4 to 6. Now, if this is like a picture and our function looks something like this, say that this rectangle is the integral from 4 to 6, the area, right? Well, the area from 5 to 6 is here to here. So clearly the area from 4 to 6 will just be this one plus this one. Which, if we substitute the numbers for everything we know that this is 2.5. Oops. This one is 7.2. What is this one going to be? If we just throw 2.5 minus 7.2 into our calculators, right, this is algebra, we'll find that it's actually equal to negative 4.7. So, and that's okay. It just means my picture's wrong, that the function actually dips below the x-axis, and it looks something like, I don't know, like that, right? And this is 4 to 5, and 5 to 6, something like that. Okay, moving on to question 2. So question 1, it was kind of like a really seeing if you know what integration means, and that's a really important calculus. So those problems, if you've got them, the rest, being able to do everything else, just comes naturally, at least for me. I don't know about you guys. But really focus on problem 1. Maybe watch over this video again, maybe watch a Khan Academy video, but that's important. Actually, from problem 2, I'm going to give myself slightly more room because summing rules. Okay, so what we're asked to do, we have a table of the rate of emissions of greenhouse gases, and we're asked to find the total emissions, like over the span of 8 years. And 2011 is t equals 0. So what I usually like to do whenever I'm writing these things, I'm going to actually write it out as an integral first, so I see what integral I'm trying to approximate. So I am taking the integral from 0 to 4 of r of t. Oh, see, I already messed up. It's a good thing we're doing this. I'm not taking the integral from 0 to 4, because what t is 2019? It's 8. So I'm taking the integral from 0 to 8 of r of t. And what is that approximately equal to? It's some sort of Riemann sum. But what goes inside of it? Well, I'm glad you asked. How about we hop on it? So this Riemann sum has, well, right-handed Riemann sum has 4 points. So that tells us n equals 4. So what is delta x? Delta x is going to be 8 minus 0. 8 minus 0, that's where we end and where we start, over 4, that's equal to 2. So the width of each and every rectangle will be 2. What rectangles do we take? Right? We have 4 rectangles. I'm going to look at the data and sort of draw rectangles over the top of them. Rectangle, rectangle, rectangle. We could make a graph. I'm not going to, but I suggest you should. Maybe make a graph and see what it looks like for yourself. Right? But if we're looking at this, we got 4 rectangles. 1, 2, 3, 4. The widths of each of those rectangles is 2. Right? That's our delta x. How do I know what the height of these rectangles are? Well, that's where this little letter r comes into account. We're taking a right-handed rule. That means we look at the right side of each of these rectangles. So, for example, this first rectangle from 0 to 2, its height will be 162.4. And this one, the second rectangle, its height will be 154. How do I know? Because that's the right side of the rectangle. So what we're going to do is say that this is approximately equal to delta x, or 2, times all of the heights of the rectangles. And I'm allowed to put this 2 out in front because all the heights or all the widths are the same. But the first height will be 162.4. The next rectangle's height, 154.6. The next rectangle's height, 152.1. And the next rectangle's height, 151.4. Okay, and if we throw that into a calculator, this yields 1240.6. Wait, but what's my unit on this? I'm glad you asked. So what R of t tells us, its unit is millions of metric tons per year, right? And whenever we integrate with t as our variable, we're sort of multiplying that unit by years. The total amount of U.S. emissions will be given in million metric tons. That's kind of fun to say, million metric tons. So I actually just looked at the next part of this problem, and you remember how I said we don't need to graph this, or you should graph this, but I won't? Well, I'm really going to graph it because of the next problem. So I'm going to, draw a rough little sketch of where all these points are. So I have T1, 2, 3, 4, 5, 6, 7, and 8. Ooh, I'll squeeze it in. Okay, and we've got, I'll say this is 170, and this is 160, and then this is 150. And then just sort of randomly, well, not randomly, but place the points as they seem to go. So 173, 167, 162.4. This is T. 1, 2, 3, 4, 5, 6, 7, 8. And it actually looks like they just kind of decrease steadily. They're not necessarily a straight line, but they decrease steadily like that. This is important, and it will help us answer the next part. So keep in mind, if we're decreasing like this, what do you think? You might take the time to draw this itself. What do you think, based off of that one problem we did in part 1, the highest sum will be? Keep that in mind. And let's move on to the next page. So in this problem, we're asked to tell, is our approximation in part A an overestimate or an underestimate? Now, think about it. Our graph had some sort of, it was decreasing. It was always decreasing, right? All the numbers were getting smaller for the rates. So if I'm taking a right-handed sum, right, this is my graph, R of t. It's a very poor. But look at yours. My right-handed sum, I'm taking, points on the right hand of these rectangles. So if you look, there's actually some area under the graph that's not being accounted for. So right-handed sum, this will be an underestimate. And I explained out loud, let's see if you can take what I said and put it into words. That since the function is decreasing, oh my goodness. Since the function is decreasing, right-handed values will be less than left-handed values. Right, so we have our rectangles and they are not filling up the whole area, so it's an underestimate. Oh, that's funny. I should have read this more clearly. We said write an integral that represents the exact total amount of greenhouse gas emissions. And that's actually what I already did. So we start in the year 0. Yep, we start when AD 0. No, just kidding. T equals 0 is when we start. That's just what we do. And then 2019, that'll be year 8, right? The function, the rates that we're integrating is r of t and dt. Don't forget the dt. It's important. Okay, so part C we already sort of talked about. Part D, I'm going to, oh, there is no part D. Well, we're on to problem 3. So what question 3 is asking, it says, for this graph, this parabola, we want to estimate this integral using 4 terms. And we actually want an overestimate. So how are we going to do that? Well, first things first, it's probably helpful to try to think about what this parabola looks like. So I'm going to sketch a graph of it real quick. Okay, so we've got, I don't know, it'll look something like this. And let's say that that's 2 and that's 4. So this isn't perfect, but from my little rough sketch, and maybe you don't know how to do this, I'll talk about how to do it if you don't immediately know how to graph these things. It kind of looks like the graph is increasing from left to right, right? Well, how do I know if it's increasing for real or not? So what I'm actually going to do, it's funny because we're taking an integral, but to know an integral, and know an estimation for an integral, I'm going to take a derivative. So the derivative of x squared minus 4x plus 6 is equal to 2x minus 4. Now, if I plugged in a number between 2 and 4 into this derivative, I would get a positive number, right? Like, take a moment, think about it yourself. If I plug in 3 here, I'll get 2 times 3 minus 4. That's 2. That's positive. That means that the graph, indeed, it really does increase from 2 to 4. Well, how do I take rectangles and make them increase, or sorry, an overestimate if they're increasing? I do a right-hand rule. That's kind of what the idea is. Right-hand rules overestimate if you're increasing. So I need to write a right-hand rule for this using however many rectangles we want. Oh, no. Sorry, using 4 terms. So 4 terms, n equals 4. Delta x equals 2, right? And a is equal to 2 as well. That's kind of a coincidence. A is where I start, A. Right, so using my sum rule, I'm going to take, oy vey, this is probably a lot of calculator work, so 1 second. I'm going to put my delta x out in front, so 2 times, I need to figure out what the height of the first rectangle is. So the first rectangle will occur at, I should have drawn a better picture. Whoop. One rectangle, two rectangle, three rectangle. We'll say that those are 4 good rectangles. The first rectangle, it looks like it occurs at 2.5. And the reason I know it occurs at 2.5, right? I break this into four equal sections. That'll be 2.5, that'll be 3, that'll be 3.5, that'll be 4. So I plug in 2.5 into this function. 2.5 squared minus 4 times 2.5 plus 6. Okay, that's my first term. That's my first rectangle. Next rectangle, my width is 2. I'm sorry. Yeah. Wait, I messed up. Delta x is not 2. Sorry, delta x is 2 over 4, which is equal to 1/2. It's 2. The distance from 4 to 2 divided by the number of rectangles. It's 1/2. So I'll just 1/2. 1/2. Not a big deal. What's my next rectangle value height? I plug in 3. It happens at 3. So I've got 3 squared minus 4 times 3 plus 6. Okay, and finally, well, I say finally, but there's 2 more. What's next? What's my next value I'm going to put in? It should be 3.5. 3.5 squared plus 3.4 times 3.5. Oops, that's a minus. Plus 6. And one more. I can't even fit it in. I'm just going to say plug in 4. And if you do that, all of it, and put it in your calculator, you're going to find that an overestimate comes to 7.75. Badum. Badum. And I did the explaining out loud. Ideally, you would explain on paper. How do we know this is an overestimate? Right-hand rules always produce an overestimate when the graph is increasing. How do we know the graph is increasing? We took the derivative. And clearly, when you plug in like 3, this is positive. So we're increasing. So let's move on to question 4. We are asked to find the formula for the left-hand approximation of f of x equals sine of x. And we're integrating summing, left-hand summing from pi over 2 to pi. So, what is a? A is equal to pi over 2. What is b? B is equal to pi. What is delta x? Delta x is equal to b minus a over n. Do we have a number for n? No, we're just using n. That's the whole point. We just want to write ln in general. Haha, in general. Get it? And whenever we do that, b minus a, pi minus pi over 2 is pi over 2. We'll get pi over 2n. Okay, so think about what left-handed sums do, right? You take your delta x times the height of a rectangle. How do we figure out what the height of a rectangle is? To do that, we have to plug in different values for sine of x, right? And for left-handed sums, there's 2 ways to think about it, and it kind of depends on your professor. I'm going to do one way that we saw in this review earlier on, and then another way that we haven't talked about yet. One way is letting your sum start at k equals 1. And what do we go to? We go to n. We're multiplying every height by pi over 2n. That's delta x. And I know that my height will have something to do with a function, the sine, because that's what f of x is. But what goes inside of it? Well, everything has to start at A. So I'm going to do pi over 2. Plus something. And I want that plus something to get bigger at each step of the way, right? I'm starting at A, and then I'm going to add something, add another thing, so that I get my next places to go with these rectangles. This is not accurate, by the way, because sine will not do that. Doesn't matter. How do I do that? Well, this is where I just multiply my delta x by this letter, k. Delta x times k. And delta x was pi by 2n times k. But wait, this is a trap. What I've just written down is a right-hand rule. So how do I make it a left-hand rule? Do -1. That's one way. And how do I know that this works? Well, I know that for my left-hand rule, my first value should actually be at A, right? This is A. This is pi over 2. So whenever I plug in k equals 1, this should go to 0. So 1 minus 1 times, well, that's 0. 1 minus 1 is 0. So we're actually taking sine of pi over 2, or sine of A, right? The other way to make sure that this is a left-hand rule is to pretty much do the same thing, but start at k equals 0. I mean, does exactly the same thing, actually. But we don't go all the way up to n. We go to n minus 1. And everything else, the whole process is the same, except that we no longer have to multiply by k minus 1. We multiply by k. That's my preference. I'm not sure what you guys are learning in class, but this is how I would do it. But it seems like your professors are doing this, so this might be the better way. Either way, they're both very similar to right-hand rules. This is probably the way to go if you don't want to make a mistake or think about how to memorize these. But they all have the same format, right? You've got delta x times f of, I'm going to write right-hand rule first. We go to n, we start at k equals 1. X of a plus k delta x. Okay, a left-hand rule, what's the difference? Almost no difference. K equals 1 to n delta x, f of a plus delta x. But what's the delta x multiplied by this time? K minus 1. And boom. That is part 2 of this review. I'll see you guys in part 3 to finish out question 5.